So I'm going to wipe off this, and then we're going to go straight on to the third equation. So third equation, it's actually an inequality. So it says x minus 1. So let me write my x in a better way. So x minus 1 squared, then greater than 9. So some of you may be tempted to expand this, which is quite fine. You can do that, or you can just recognize that if you take the 9 to the side, then it becomes difference of two squares. Okay, in what sense? 9 is simply 3 squared. Okay, so I can here now I now have this square here, and I now have this square here. They're separated by a difference. So this is really good for me. It means that my factorization can be really quick. Okay, so here I just need two brackets. So I'm going to put my two brackets here. And then obviously it's greater than 0. And then in the first bracket, I'm going to put my first number, so which is x minus 1. Here, the root for the first square. Okay, so this is what I'm writing. So the root for the first square I'm writing on the in one side, and then also on one side. And then the second square here, the square root would be 3. So I'm supposed to write plus 3 and then minus 3. This is based on the general formula for the general formula for factorizing difference of two squares. Okay, so whenever you have x squared minus y squared, you'd get x here, then you'd put x here, and then you say plus y, then minus y. In other words, the square root of the first square comes first, okay, in each bracket, and then you add and you subtract alternatively for the second square. So here, if you actually notice, we have x minus 1 plus 3, so you just get x plus 2. And then here you have x minus 1 minus 3, then you get x minus 4. And this is greater than 0. So your roots, you're supposed to be clear about what your roots are. So your roots would be x equal to negative 2 here, or x equal to 4, okay? So this ones would be your roots if you were solving an actual equation, okay? But then this is an inequality. I'll show you where the roots would be proposed, okay? So here you'd be just writing your general equation for, you can say f of x is still fine, you can say y, it's still fine, okay? So our graph would it be smiling or would it be frowning? I think our graph would be smiling. Why? Because the coefficient of x squared for this case would be positive, okay? If you expand this, you actually get x squared, then the rest of the equation, okay? So if x squared, the coefficient is positive, then it means that our graph would be smiling. So I'm going to write this. It's smiling as opposed to frowning. Frowning would be this, okay? So I think that's how you'd basically present someone who's frowning. So here, our graph, we say that it will be smiling, or it would have a minimum, to be more technical, okay? So after doing this, now you have your value, so you can actually put this is negative 2 and this is 4 here, okay? These are the roots that you're talking about, that we were figuring out here. So now you want the regions where this expression, this expression is greater than 0. So obviously it'd be these regions here, okay? So in other words, what's greater than 0 here are the y values. So if they say they want the y value is greater than 0, so you have to shed on the part of this, and then whatever area that you shed, it has to be between the x-axis and the graph, okay? So here, if they had said less than 0, then we would have done the shading on this part here, okay? But then they didn't say that, so we are stuck with this. And then the way that you present your answer would be to say x is obviously less than negative 2 here, okay? And then you say union. Union is just a way that we unite two kind of contradictory results. Then they're not really contradictory; they're just separate, okay? So you can unite them. So x is greater than 4, okay? So this would be your ultimate equation. So this is how you go about it. Remember, you can avoid you can skip some steps by just applying difference of two squares instead of expanding this whole thing, okay? So you apply difference of two squares. After you apply difference of two squares, then you can get to a place where you have you can determine the roots for the equation. If it were an equation, you use these roots on your graph here, so that you can ascertain the inequalities, okay? So Remember, the area that you shared is supposed to be bound by the x-axis and the graph, okay? So depending on what you're told. So this has been really some fun exercise. I hope you understood it very well. I'm going to skip over to the last part, okay? The last part